slope. This will help you when you're graphing. If the slope is like 1/2 or 3/2 and your line is not going up this direction, that means you didn't graph it right. What kind of slope goes this direction? Negative. Good job. So when we are graphing, you can always check yourself to make sure you're doing it right. So always check the way that your slopes are graphed. It's the easiest way to know if you went the right direction. All right, what kind of slope goes like this? Zero slope. A zero slope, when I have a fraction, where does the zero go? Top or bottom? The top. And then there's just any kind of number on the bottom. It doesn't matter what that number is, but when I'm graphing it, it's going to go left to right. So remember the trick. You can make this look like a Z to help you remember that it is zero slope. Okay? You don't actually write the word zero. It's just kind of a mental reminder that it looks like a Z. Okay? What kind of slope goes vertical? Undefined. When a slope is undefined, in our fraction, where does the zero go? In the bottom. This is where, if you're typing it all into your calculator, it gives you an error. It says can't divide by zero. That's because the slope is undefined. That doesn't mean you did something wrong. It just means the slope is undefined, and that's okay. Remember the trick here? You can make that look like a U for undefined. What does it mean? So we're going to kind of shift from graphing just equations of lines to comparing actual slopes. What does it mean for slopes to be parallel?
Like that.
Okay, what does this mean?
Parallel.
But like, yes, it does mean parallel. But like, if I was going to look at the equations of the lines, if lines are parallel, what does that mean? They don't touch each other, but what about their slopes? Yes. They're what? So parallel lines, they're lines that don't touch, but what's true about their slopes?
They never cross. Zero.
Yes, they don't cross. Not necessarily zero. So for us to say that the slopes or the lines go the same direction, they never cross, the reason that happens is because their slopes are the same. They both go up and to the right too at the same time, or down and to the left. So parallel slopes, they are the same slope, different y-intercept. Meaning that they're not going to cross, and they're both not going to go through the same y-intercept because that would just be the same line. They would just overlap. To show that two lines are parallel, you draw small, solid arrows on them. Like this. So remember how you learned congruent? You use bars to show that they're the same length.
Is that a point?
These are solid arrows. So that shows parallel. That means that they're going the same direction. So when we talked about congruency, you use little bars. Parallel means they go the same direction, which is why we use arrows. For example, for same slope, if we have an equation of a line y equals 2/3 x plus 2, and y equals 2/3 x minus 7. Okay, in these two equations, notice how we have different y-intercepts here, but our value for slope is the same. The value for slope is 2/3, 2/3. That's the same number, which means that they are parallel. That's all that means. When you graph it, their lines are going to go next to each other. That's all. So parallel slopes, same number, exactly the same. This is also why when we reduce our fractions for slope, it's really important to simplify them so it's easier to compare. Okay, you want to simplify so it's easier to compare. Perpendicular slopes are the tricky ones. Perpendicular slopes are opposite reciprocals. Opposite reciprocals. Now, that's just fancy math terminology. We can break that down into simpler terms. So the term opposite just means different sign. One is positive, one is negative. So the term opposite means different sign. One is going to be a positive slope, one is going to be a negative slope. The term reciprocal means that it is a flipped fraction. So when we're comparing, our fractions are going to be flip-flopped, meaning one of them might be 2 over 3. The other one would flip to 3 over 2. Then their signs will be different, meaning one of the slopes will be positive, one of the slopes will be negative. In order for it to be considered perpendicular, both of these things must happen. So perpendicular lines look like this. What kind of angle do those cross at? 90 degree. How do I show 90 degree on this picture? Okay, with a little tiny box. So 4 90-degree angles are there. So some examples of opposite reciprocals. Let's say we had the equation y equals negative 5 over 2x minus 7. And I'm just making up an equation. Negative 5 halves x minus 7. For a slope to be perpendicular to negative 5 halves, I need the equation of my next line to flip the fraction. So which number should be on top now down here? 2 over 5. Do I need to make this negative or positive? Positive. Why do I want it positive? Yes, I got to flip the sign. So this one was negative, this one's positive. The top and bottom flip-flop. And then we can just make the rest up. So notice how the slopes in this case have flipped and the signs have changed. Now, if that does not happen, and let's say that it just flip-flops and doesn't change sign, then it's neither. It's not parallel, it's not perpendicular. They're just two random lines that cross. That's it. Yes, Gabe? Did what? No. To make a whole fraction negative, you only need one negative sign. So all you're going to do here is just take the negative away, and it will make the whole fraction positive. I just made that up to continue the most important part is the slope, whereas these have different y-intercepts, just showing that they're the different lines. Okay, so let's practice. We're going to practice to see if these slopes are parallel or perpendicular. So I did not give you an equation like down at the bottom. So in order to determine if AB is parallel, perpendicular, or neither to CD, all you have to do is the slope formula, which we have done since the first page. So all I'm going to do is label my points. Here's x1, y1, x2, y2. So the first thing I'm going to do is I'm going to just break these up. I'm going to do the slope of these 2 points first. Then, once I get a fraction answer for that, I jump over here and I do it again. Then I compare. So what is the equation for slope?
Y1 minus y2 minus y1 x2 minus x1.
Good.
So,
Yes, ma'am.
so where did you get the 3 out of the?
I just made that up.
Oh,
The only part of the problem that matters is this part, the slope. I will not make a problem anymore. Yeah, all that is just a way to finish the problem out. So it's a full equation.
okay.
All right, just gonna get y2 minus y1.
That's from y2 or
Hmm.
something. You use y down or something.
Yeah. I use this white out tape. Okay. So we're going to substitute and simplify. Oh, that zoomed in way too fast. There we go. So y2 is 6.
minus
Mhm.
3.
Good, minus 3, which is y1 over
3.
4 minus 2, x2 minus x1. What does that fraction simplify to?
Go down to
6 minus 3 is 3. 4 minus 2 is 2. Okay. Then all we do is hop over to the next group. x1, y1, x2, y2. So take a second and find the slope of the next set of points. For this one, I got 6 over 4. What should I do with, oh, just kidding, you can't see any of them. Okay, I got 6 over 4. What should I do with that answer? Divide it. So what do I get when I simplify 6 over 4? 3 over 2. Now, what we're going to do is analyze the slopes. I have 3 over 2 and 3 over 2. Are they parallel, perpendicular, or neither of those? How do we know they're parallel? Slope is the same. Good job. So my answer is just parallel. Does anyone remember the symbol for parallel? I'll tell you that it's hidden in the way the word is spelled.
The 2 L.
There you go, Nick. It's the 2 L's. The symbol for parallel looks like this. You can write it up and down, or you could write it slightly tilted so you don't think it's an 11. Both of those are correct. It really just depends on how you prefer to write it. But yes, the symbol for parallel is literally in the word as long as you spell the word correctly. It is in the word. Yes, like train tracks. Hopefully train tracks never cross. Then,
They do.
yeah, but the same track.
Oh, still.
Oh. All right, I want you to try the next 2. So remember, do the first group and do the slope, and then analyze the second group and do the slope and compare. The first one I did 7 minus 3 over 1 minus negative 2. Bless you. The double negative would turn to plus, or if you're typing it in your calculator, you can put 1 minus negative 2, and it will simplify it for you. So it's really just your preference. Yes, you get 4 over 3, positive 4 over 3. Then for the second one, you do 1 minus 4 over 6 minus 2. 1 minus 4 is negative 3, and 6 minus 2 is 4. If you're doing it in your calculator, that's totally fine, but make sure that you're putting the whole numerator in parentheses. Let me pull this up a little. So if I'm going to type the first one in my calculator, I would do parenthesis 7 minus 3, close parenthesis, divided by parenthesis 1 minus negative 2. I would get a decimal, and then I would just press math, enter, enter, and I would get 4 over 3. So you can do it all at once, but you have to put the numerator in parentheses, and then the division sign, and then another group of parentheses. So looking at these slopes,
That looks like a fancy calculator.
it's not that fancy. All right, parallel or perpendicular or neither? Because remember, neither is an option too. Okay, perpendicular. How do we know they're perpendicular? Okay, flipped and different signs. It has to be both. So if for some reason, let's say we had gotten just 3 over 4, that only flipped the fraction. It did not change the sign. So you must do both. So this is perpendicular. The symbol for perpendicular looks just like perpendicular lines. It looks like an upside down capital T. So you can write the word or you can write the symbol. It is completely up to you. All right, let's determine if 2 lines are parallel, perpendicular, or neither. So now at the bottom, same idea, But it's a little bit less work because now we have equations of lines. You cannot do the slope if it's not y equals something. Okay? So if it's in point slope form and you can see a slope, that's fine. But this, I have no idea what the slope is. So how do I find the slope of this line? Subtract what? 3x. Good. Am I going to put that underneath the 4? Can I combine 4 and negative 3x? No, I'm just going to put it off to the side. Remember, x's and just regular old constants, they can't go together. I'm going to bring down my 2y. Which value do we put first? Good. Then I bring down my positive 4. What's next? How many times? 3 times. Good job. You want to write it each time because it is very, very easy to forget it. So if you just write one big division line, that's not good. So these cancel, and I'm left with y equals. Can negative 3 over 2 simplify to anything? No. What about positive 4 divided by 2? Positive 2. And then you're done after that. Do I have to do anything special with the second equation? No, it's already y equals. It's already done. So what kind of lines are these two? Parallel, how do you know? Same slopes. What are the slopes? I want to make sure we know. Negative 3 over 2. I've got one here and one here. I don't have to do anything with this problem. Don't make it harder than it is. There's nothing to do with the second part. Yes, we do not care about that. All we care about is what the slope of the line is. That's it. And the slope, remember in y equals mx plus b, which is point slope form, the slope is represented by what letter? M. That's why we only care about what is in front of x, because that's what slope is. The rest of that junk, that just tells me how to graph it. Go here on the y-axis, do all that stuff. All I care about is how does the line move up, down, left, or right. That's all I need. So that's why I kind of just ignore that last part. And one thing I want to brag on you all about is we are doing so good when we have to identify slope that we're not including x in that. For years, everybody's always like, oh, the slope is negative 3, 2, x. X is never a part of slope, and you guys are doing really well with not doing that. So good job. I'm proud of all of you as individuals, okay? All right. I want you to try the next one. Remember, don't overcomplicate it. If y is already by itself, you're good. So try the next one. Determine if it's parallel, perpendicular, or neither. Okay, on page 25, I got 1/3 as my slope. How do we identify slope here? Plus 3x. Do I put that underneath the 2? Nope. Good. We're doing really good with solving these. Y equals, what's the rest? 3x plus 2. What's my slope here?
Oh, it's your view, dude.
I'm what? What's wrong? Oh.
You're muted, Miss Owens.
Aw, thanks for telling me. Cody's just like, I'm just going to let her keep speaking to no one. Okay, so we get 1/3. Then here we subtract or add 3x. Then we're left with y equals 3x plus 2. So what's our slope? I'm sorry, I got distracted. It's 3. What kind of slopes are 1/3 and 3? So we got neither and we got perpendicular. I'm glad that we didn't say parallel, so good job on that. Oh, now I'm disappointed. I did. Okay, so I have 1/3 and 3. Let's write them out separate, okay? If it's hard to see, I'm going to write 1/3 here. I'm going to write 3 here. Well, 3 is not a fraction. How can I make 3 a fraction? Put a 1 under it. Do those look like opposite reciprocals?
Yes.
What is opposite reciprocal?
Oh, yeah.
No. Okay, are these slopes opposites or reciprocals of each other? What does reciprocal mean? Yeah, flip, reflect them. Opposite, the term opposite means what? Different signs. Are these different signs? No. In order for it to be perpendicular, okay, for it to be perpendicular, you have to have opposite signs and flipped fraction. I have the flipped fraction. That's good. I do not have this part. That's bad. So that means perpendicular is out of the question. It's got to have both. So that means my slope is neither. Does that make sense? Confusion? Is there anything? What is confusing you on those? Because I heard both of the correct answers. I heard neither and I heard perpendicular. You just got to be careful. Can we see that those don't have opposite signs? Yeah, they have to have both. You've got to flip it and the signs have to be flipped. Now, if I have just a 3 like this, put it over 1, make it a fraction, make it easier to see. All right, it's okay to have an answer of neither, and I just realized right here I did not write parallel. There we go. Okay, let's do page 26. So we have done a lot of slope, we've done a lot of solving slope, we've done a lot of comparing slope. This is going to kind of put it all together. Everything we've done kind of builds on itself like a snowball. So we started with y equals mx plus b. We moved into point slope form. We've done a ton of stuff solving for y, isolating a variable, all that good stuff. Brings us to page 26. Okay, so the progression of this chapter, everything builds into itself, which is why we spend so much time on some of these topics. The state test really likes questions like this. They're good. They're like, oh, great job. You can calculate slope. They want to make it a lot harder, right, Luis? Yeah, right? A lot more difficult, okay? This might look intimidating because, one, there's a lot of words. The IXL looks a little intimidating because there's a lot of words. This says, write the equation in slope-intercept form that is parallel to the line given and goes through the point shown. It's a lot of stuff. Whenever you're reading a word problem and you're confused, read it all the way through. Just power through it, even if you have no idea what you're reading. Then go back and reread little sections of it. So we want to write an equation in slope-intercept form. What is slope-intercept form?
Y equals mx plus b.
Good job, Cheyenne. Y equals mx plus b. So right above here, I'm just going to write it. Y equals mx plus b. Write a reminder to yourself so you know what the form is. We've learned a lot of forms. We want a line in y equals mx plus b that is parallel. What kind of slopes are parallel? How do I know they're parallel?
They don't change.
Same slope, good job, and they don't change. So parallel means same slope. And it has to go through a specific point, which means if I'm given a point and I'm giving a slope, I have to start in point slope form. Remember, we name lines based on what we need to graph them. So I've read the question, I know that I need to put it in slope-intercept form, and the slopes have to be the same. So the first thing that we're going to do, step 1, is to identify the slope. What is the slope of my line? What's the slope of my line? No, 5's a point. There's no negatives here. 3. Remember, in front of x is slope. So the value in front of x is 3. So I'm going to identify my slope. My slope is 3. Do I need to change this, or should I keep it the same? If I want my slope to be parallel, should I change 3 at all? No. Parallel means same slope. So I'm going to write right here, parallel. I want my slope to stay 3. I don't want to change it. I know that I want it parallel because it is telling me right here, hey, make the slope the same. Literally, we've done no math. We've just identified 3 and we just wrote it down. Okay. Step 2 is to substitute the point and slope into what line equation? Should I substitute my point and slope automatically into slope-intercept, or should I plug them into a different equation? If I have a point and I have a slope, what line should I start with? What equation uses points and slopes? I don't have a y-intercept and slope. I have a point and a slope. So what form of line should I plug those into? We've only learned 2. All right. I've got a point and a slope. What form should I use? No. We learned 2 equations of lines. We learned slope-intercept and one other equation of a line. What was the other name? What is it? It does start with a P. I'm pretty sure you do. Those aren't equations. It's okay, guys. We're just going to scaffold back up. We can do this. Slope-intercept is what? No. No. Those are types of slope.
Equations. What equations have we learned so far this week? Last week. What equations? Up there you see slope-intercept.
Yeah, that's one of them.
One of the equations, y equals mx plus b. What's the other one? Say it again.
Point slope form. She said PowerPoint. Definitely an equation of a line. Okay, we're doing good. We're going to plug it into point slope form. I know, that was really painful, but it literally says right here, point slope. Point and slope. Plug into point slope form. Oh, well, that's your handwriting. That's not my fault. All right. So let's go back. What is point slope form? Okay, y2 minus y1 over x2 minus x1 is slope. I want the equation of a line which has to have x and y in it. Y minus y1. Good. There we go. It took us a while, but we did it, and that's all that matters. Oh, sure, yeah, blame it on that, yeah. Okay, so that is called point slope form. It is called point slope form because to graph the line, I need a point and a slope. Point slope form, okay? So step 2 is to substitute into this form. How do we label point A? X1, Y1. So there's our point. We already have our slope. So let's substitute. Y minus what?
3.
Good. So here's the 3 equals what?
M.
What is M?
M.
M is 3. Yeah, parenthesis, what? There we go. We took those. Remember, we're using this slope. We did not change it because we want it to be parallel. You've already done this for days. You've been plugging points into point slope form and simplifying. You've done this already, okay? None of this is new. It's just now we're piecing apart all of the math and just rearranging it into a new type of problem. The math is the same. The presentation is different. Now, our goal is to put this into slope-intercept form. What should our next step be? How do I get that into slope-intercept form? What should I solve for? Okay, we're going to distribute. What variable do we want to solve for? What? We want to solve for y. So the final step, step 3, is to solve for y. I just think you all are silly all the time. Okay, so we're going to distribute. That's the first step. We want to get rid of those parentheses, the orders of operation. So when I do that, I get 3 times x, 3x. What's 3 times negative 5? What kind of 15? Negative 15. All right, y is still not isolated. What's next? Plus 3. Where am I going to add the 3 on the right-hand side? Negative 15. Good. We don't want to put it underneath x because 3x and 3 are not like terms, so they cannot be combined. No way. I get y equals 3x minus 12. And you're done.
15.
3 times negative 5 with the distributing. Okay. We're going to skip number 2. And I want you to do number 3, which is the same exact type of problem. So skip 2. 2 is with perpendicular. So before we forget how to do this, I want us to jump down to number 3. And we're going to do that underneath the Let's Practice bar.
I'll try.
So it's parallel, which means I don't have to change the slope. I keep it the same, which means my slope is 2/3 because I want it to be parallel. My A value is my x1, y1. Now I'm going to put it into point slope form. I cannot just automatically do slope intercept. You've got to work your way up there. So you have to start with y minus y1 equals m parenthesis x minus x1. We okay with that formula? We've done it a lot. Let's substitute. Y what? Okay, minus negative 2 or y plus 2. Up to you, don't care. I'm going to leave it as minus and negative for right now. Equals what? Yes, 2/3, what? Parentheses x minus 5. Okay, now I'm going to jump and simplify. We've changed these to positive, so I get y plus 2. What should I do here? Distribute. So 2/3 times x. 2/3 x. 2/3 times negative 5. Negative 10/3. Are we confused on how to type that into our calculator if we don't know how to do that by hand? I'll just go ahead and do it real quick. All you do is 2 divided by 3 times negative 5. I get a decimal, math enter, enter, gives me negative 10/3. Now what? I got a minus 2. Where do I put that? Over the 10 over 3. Because this doesn't have an x, so I don't want to put it here. So this goes away, and I'm going to just rewrite that up here. Y equals 2/3 x did not change. However, now I want to subtract 2. So I'm going to do parenthesis negative 10 over 3 minus 2. I get another decimal. Math, enter, enter, gives me negative 16 over 3. The state test does have a calculator and non-calculator portion, but this would be on the calculator part. So you don't have to worry. If you need to use a calculator to do that, it's totally fine. I don't mind at all. Does it make sense now that we've done it again? Okay. Let's do perpendicular now. Tomorrow, we're gonna finish the notes today, but tomorrow, oh, I know, terrible. Tomorrow we're gonna do IXL all day over page 26. We're gonna spend all day doing this. I know, terrible. So I became a teacher so I could torture you all. You're gonna skip tomorrow? Good. It's good. I'm proud of your dedication to education. All right, we're not done. We're doing page 26. Oh, I know, the torture. I thrive on all your sadness. You're gonna drop this class? Good idea. I think I'll sign the paper for you. You don't need this class? Okay, then you're good. Okay, here we go again. All right, page 26, we're gonna go back up, and this time we're gonna do perpendicular. Here's the thing, same level of difficulty, only I just need to change my slope. So, how do I what? Because this is a perpendicular slope, and I wanted you to do a parallel and a parallel example, and then we're gonna go back and do perpendicular and perpendicular. That's okay, that's why we're gonna practice tomorrow. Yes, we're going to change our slope and make it perpendicular. And then the steps are literally all the same. So we want to write the equation in slope-intercept form. What is slope-intercept form? Y equals mx plus b. This time we want to make our slope perpendicular. What does that mean? Negative and flipped. So we need to do opposite reciprocals. So we're going to write the math word, but no, opposite reciprocal just means change sign, flip, fraction. So here's our equation that's given. Here's our point. Step 1 is to make the slope perpendicular. Make the slope perpendicular. What is our original slope? 5 over 2 is our original slope. But do I want to keep it the same? No. So I'm going to go over here and I'm going to write 5 over 2. How can I change that to make it perpendicular? I'm going to make a negative. What does my fraction do? 2 over 5. Good, it flips. So this is my new slope. That's the slope I want to use. The math is the same, only now we're just changing slope. Hey, Cody, go ahead and shut your mic off for me, okay? I think you hit it by accident.
I guess I did.
It's okay. All right, the next steps, they're literally the same thing. Step 2. Substitute the point and new slope, because we now have a new slope, it's not the same anymore, into point slope form. the next step? We want to use our new slope. So I'm going to write point slope. Y minus y1 equals m parenthesis x minus x1. Let's substitute. I've got x1, y1. Remember, step 2 is to substitute into this equation. So I get y minus what? Good. Y minus negative 2 equals, there we go, negative 2 over 5. And it's okay to either put the negative in the top or in the bottom, but you can't put it in both. Parenthesis what? There we go, x minus 3. See, this part is the same. You've been doing this. We've substituted. What's our next step? We are going to distribute. Well, what's our end goal? There we go, solve for y. Because we want it to be in y equals mx plus b form. So now we'll distribute. So what happens here? Yeah, y plus 2 equals, let's distribute. Negative 2/5 times x is what? Negative 2/5 x. What's negative 2/5 times negative 3? 6 over 5, good. Positive 6 over 5. We're going to get some fractions. It's okay. The fractions come from whenever we have a fractional slope. Fractions can exist. What's next? There we go, from what? There we go. And I'm going to rework it right here. So I get y equals negative 2/5 x. What is 6 over 5 minus 2? No. No.
2.
No.
Negative 3.
Have you typed this into your calculators? I got negative 4 over 5. Are we shouting randomness?
Yeah. Negative 4 over 5.
All I gotta do is 6 over 5 minus 2. Enter. I get negative 4 over 5. We good?
Yeah.
Whew, that was rough. Notice how this problem is literally the same as the top one. The only difference from this top one or this bottom one is we have to change the slope. That's it. You know how to use the formula. You got a different fraction? Oh. You know how to use the formula. The math is the same. You know how to flip a fraction. You know how to solve for y. All it is a different way to represent what you're learning. Okay? We will do example number 3 tomorrow, or example number 4 tomorrow. I have to spray your desks down. So we did not finish the notes. So I'm sure you all are happy. Yeah, yay. So tomorrow we'll finish that example, and then we will be doing IXL. Okay, we'll be doing IXL. So make sure your laptops are good and charged. Coach Webb and I are going to come grab your calculators, and then I'm going to spray your decks.